afternoon, children. Now we discuss about the another topic in this refraction of light through surfaces. Already we discussed plane surfaces. Now we discuss about curved surfaces. This is very important. That means in curved surfaces we have to make lenses. So we have to consider here lens. By making that lenses, so optical lenses is very important for vision, for all of them. It is very useful. So this lens will be how it will be made and what is the principle involved in it. To observe, the principle involved in this lens will be the working of lens based on refraction of light. So what is the principle in? So it is a lens principle. Or principle of lens. So what do you consider the principle of lens? Refraction of light. Refraction of light. It is the main principle involved in it. By this, these lenses are constructed. So lenses are constructed by this principle, refraction property only. On this basis, we have to construct this. Mirrors on the basis of reflection. So observe the difference. Mirror differ from lens. So in mirrors what happens, at one side will be coated in mirrors, but in lenses two surfaces will be bounced together, light will be propagated through it and shed in lenses. But in mirror what happens, at one side will be coated, only at one side the light will be false, from there it comes back, means in that reflection will be takes place. In this part refraction, in lenses refraction will be takes place. So diffraction means a lens is a piece of transparent glass bounded by two spherical surfaces. If two spherical surfaces are bounced like this, then this lens is formed. Okay. So the a lens is a piece of transparent glass bounded by two spherical surfaces. In this, two different types will be there. Types of lenses. Types of lenses. There are two types of lenses out there. One is convex lens and another one is said to be the concave lens. Convex lens and concave lens. Two lenses will be there. So by bouncing with different kinds will be formed, but mainly these lenses are classified these two types, convex and concave. First we discuss about the convex lens. Convex lens we discuss about. So mirrors also be two types, that is also convex and concave, that is mirrors. Now we discuss about the lenses. These are the lenses, later we discuss about the mirrors. Okay. Now these lenses means two spherical surfaces will be bounded together by transparent nature. In this convex what happens, if the two spherical surfaces of lenses are convex, it is known as the convex lens. Two surfaces, spherical surface of the lenses are in shape of convex. Convex means, see, in this structure. This is the convex structure. Convex means edges will be lean and the center part will be thick. So thicker part is at the center and these edges are said to be the lean. This is called as a convex. This is called as a convex. Such a lens, these two spherical surfaces will be attached like this. This is called as a convex lens. Nowadays what happens, the symbol of this lens also be given. So it is actually to define according to the definition, we have to like connect it. This is a one spherical surface and this is the another spherical surface. These two spherical surfaces are to be bounced, means to observe. So this is the one spherical surface. It's a one spherical surface. It is one spherical surface and then it's the another spherical surface. These two spherical surfaces are bounded together. So attached together. Here, this part will be behaves as a lens. So this is said to be the lens. Understand? This one. What is this? Edges will be. To remove this, so edges will be behaves as a convex lens. This is to be removed. This part. So shade to be made means only the center part to be considered. This is the convex. So like this convex will be formed. It can represent it symbolically just to draw this line and indicate up and down arrow marks like this. This is the convex lens. Nowadays I will indicate like this. No need to draw complete this structure. Just try to draw this. It behaves as a convex lens. Okay. Now in this section, that means in this class, that is in this diffraction of light, mainly you have to use this convex lens only. Why? Because it will be acts as a converging lens. Converging. So previous I told you converging and diverging. Two will be there. Here rays. The rays will be, the light ray will be travel like this. These are called as parallel rays. Remember that. These rays will be called as a parallel rays. These are called as parallel rays. Parallel rays we call this one. And the rays all will be meet at one point. They are coming from different sources and they are all meet at one point. So they are all to be meet at one point. They are coming from different sources, but they are all meet at one point. Such a rays are called as converging rays. These are said to be the converging rays. Similarly, from one point of source, all the rays are deviated like this. All the rays are deviated from one source. Such a rays we call as a diverging. So here to observe the converging and diverging difference. From one point, all the rays comes out. So to indicate the direction to output, which direction the ray of light will be propagated or traveled, that to be indication. Remember that. In this direction it will be propagated means from one point all the rays will be deviated. So these are called as diverging rays. These are said to be the diverging rays we call this. So converging, diverging. So mostly you have to use this converging. In this case also, this lens behaves as converging. That's why mostly you have to explain all the applications and all the things, how the ray will be propagated. All such things will be discussed about by this convex only. Okay? Concave also there, but mainly we discuss about this converging lens. Understand the converging and diverging and parallel. So parallel beam of lenses, they travel straight. Okay. Now, what is convex lens? Two spherical surfaces are bounced together in convex shape. In convex, this is called as a convex. Means edges will be thin, center part will be bulging. Bulging. That means it will be thicker part will be. Similarly, another lens will be taken as concave. Concave lens. In this what happens if the two lenses, if the two spherical surfaces of lenses are concave, it is known as a concave lens. Two spherical surfaces are concave. Means, so this is the structure. This is one structure, and this is another concave lens. These two will be bounced like this, combined together like this. So in this what happens? Edges will be thicker. See, observe. Edges are thicker part, and center part will be lean. Such a lens we call as a concave, and symbolically it can represent it as, so nowadays symbols also important. Remember like this symbol. So I have to be reversed to draw. This is the concave. Means how it will be formed? To observe two spherical surfaces. This is the one spherical surface, and then this is the another spherical surface. This is the another spherical surface. To attach these two spherical surfaces, to combine these two spherical surfaces. So, what happens here? Edges will be thicker. Understand the difference between concave and convex? Here, edges will be thicker, and center part will be lean. So, rest of part to make dotted lines, then we get the lens part. So, like this. So, this part, this is said to be the concave. Okay, edges will be thicker and center will be very lean. This is said to be the concave lens. Okay, so it's not very important. So in this part, these two lenses are very important. So if the lenses are in spherical surface, some important properties or characteristics we have to discuss. So important characteristics of these lenses or properties of the lens. What are the properties will be there that we have to discuss. So characteristics of lenses. Characteristics of lenses. Characteristics of lenses we have to discuss. Here for both cases we have to discuss concave and convex. In both cases, I had observed these definitions. So, first I have to consider convex lens and concave lens. Concave lens to be observed. So, convex lens means that one. Concave lens is two spherical surfaces are to be bounced together. So like that. Here, these two spherical surfaces will be attached. So in this, we have to say the optic center. Optic center means the center point of the lens is known as the optic center. The center point of the lens. Center point of the lens is this one. The center point of the lens we call as an optic center. First definition is said to be the optic center. So what is optic center? The center point of the lens. The center point of the lens is called optic center. It is denoted by the letters P. So the optic center of lens has the property that a light ray passing through it does not suffer any deviation and goes straight. Suppose any light ray passes through this optic center, it does not be deviated. It will be passes straight only. So it does not deviate. So that is its main property. And another property to say center of curvature. Center of curvature. So center of curvature is the property of the center of the spheres which contact parts of the curved surfaces is called the center of curvature. So the center of a sphere which contains the part of curved surfaces. So for these lenses, this is the center of the lens, spheres. This sphere's centers. The center of the spheres we consider as the center of curvature. Center of the sphere. Simply remember that center of the sphere center, which can contact with this lens. Such a part we call as a center of curvature, and these are denoted by the symbol. Actually, center of curvature is denoted by C, but it having two values, that are C1 and C2. So it contains two curved surfaces. So then the centers of curvatures are denoted by C1 and C2. So these are denoted by C1 and C2. C1 and C2 to be considered as the center of curvatures. Okay, so the center of this sphere, but it having two centers because two spherical surfaces are to be attached. That's why two center of curvatures which having, that are C1 and C2 had to call. Now principal axis. So the line passing through the center of curvature to optic center is called as a principal axis. This line is called as a principal axis. So the line which passes through the center of curvature. Understand? Center of curvature and optic center. So optic center and a line joining to the center of curvature, optic center. So such a line we call as a principal axis. So the principal axis of a lens is a line passing through the optic center of the lens and perpendicular to the both lenses of its lens. Both it will be, it is one surface to be considered, it is perpendicular part, it is considered another part, it is taken as the perpendicular to that parts also to be defined. Now another definition to consider as radius of curvature. Radius of curvature. So radius of curvature can be defined as the distance between the center of curvature and the curved surface is called the radius of curvature. So from center to, it is a curved surface. So from this curved surface, any point we consider from center of curvature to point. So from the center of curvature to any point on this circle, we consider as the, so these are C1 and C2. These are represented as radii R1 and R2. Radii of curvature. Radii of curvature. So once again I repeat, for this concave lens, two spherical surfaces are bounced together. The center of the lens is called as a optic center. Center of the lens is called as a optic center. It is denoted by the letter P. And then another one, to the center of the spheres. The center of the spheres, which is part of a lens, is said to be the center of curvatures. So it having two center of curvature values. That's why they are called as C1 and C2 to be indicated as C1 and C2. And the line passes through the optic center, which are perpendicular to the center of curvatures, or said to be the principal axis. This line is said to be the principal axis. From center of curvature to any point on this curved surface is said to be the radius of curvature, but it has two radii, R1 and R2. Two radii will be there for this. Okay, this is about for the case of concave lens. Similarly, this can be defined in case of convex lenses also. So same definition. Same part of convex lenses also we have defined. The center of this lens we call as the optic center, and then the center of the spheres we consider as the center of curvatures, and the line which passes through this is called as principal axis, and from there a line which will be joined from center of curvatures is considered as the radius of curvatures. For that concave lenses also have to consider. So these three properties are very important. Two more properties will be there that we will discuss in next class. Okay, thank you.